I'm going to show you a short clip from the Flat Earth Debate Show, or what I call the Flat Earth Gossip Show, and show you how this group of panelists convince themselves that the equinox works on the flat Earth. Now, the show was already in progress when I joined, but before we go on, let's just take a quick look at this photograph. Look at these wind turbines in the back here. And if you look right here, just to the right of center, all you see is the top blade of a turbine. How do you look at this photograph and come to the conclusion that this is possible on a flat Earth? But anyways, let's continue.
Yeah, they're trying to answer why questions and not like science. These are all philosophy. You know, they're all just saying, well, why is this? Why is that? And how would you test these things that they're asking?
It's a proud day for me, Spurs.
That's what they're asking. That's what we're asking. That's what we're looking at here. You know,
My
why
point
this?
was,
Why that?
how why questions outside the limitations, if you will, of science. You're trying to establish cause and effect relationships with science. That's what it's for. Not answer how why questions. But just nice to hear
How
you
why
say
questions
that.
are cause and effect questions.
Say again?
Well, I think that last comment was correct, that why questions can be cause and effect. So I wrote this over here in the red box. Yes, we are trying to answer why questions, such as why do we see the sun rising in the southeast and setting in the southwest right now? So what is the cause of this? And then I continued when the flat earth model shows the sun rising in the northeast and the northwest. So a few minutes later, this came up.
Just why? He wants to know why the sun rises due east for everyone on the Earth on the equinox. Why?
Oh my God. Really? Due east. They need to define that. As in asmus? And that's incorrect.
Now, I was referring more to the December solstice because currently the sun is rising more to the southeast and setting in the southwest. And to be honest, I would even have to wonder if anyone on that panel could tell me what the current direction of sunrise and sunset is. But let's talk about the equinox. So here we have a compass, and over here this would be in the general direction of east. And yes, we do have a definition of due east, the cardinal compass point that is at 90 degrees. And this is how it works on the globe. This is the time of the year when the terminator line is aligned with the north-south axis of the rotating Earth. So everybody from the northern to the southern hemisphere sees the sun rising to the east.
It doesn't even do it anyway. Cyclone Bakara Diane, she demonstrated using stellarium, her chosen weapon of attack, that at the summer solstice and the winter solstice, the sun did not rise due east on the day in question at all four corners, like she claimed. It was out by a degree and a half. That's a problem for them because it's got to be due east for them, and it doesn't do it.
Yeah, and Jaron exposed this in 2015. I forgot, their model's not Google Earth, right? He showed using back asmus and stuff that it doesn't work. So, next question.
And that was it. So Anthony basically said the sun did not rise due east. That's a problem for them or the globe, but that's not a problem for the flat earth. And then someone else said Jaron exposed this in 2015 on Google Earth. He showed some back azimuth and stuff. And how does that relate to this? And then finally, next question. So where was the explanation of how the equinox works on the flat Earth? So let's start with this Jaron issue. Here I have a star and it's on a latitude. So to the right would be east and to the left would be west. And this would work the same on both the globe and the flat Earth model. Now Jaron was using the line tool on Google Earth. And if you start that line tool here at the star, and head off at an initial heading of 90 degrees, it is going to curve downward and eventually intersect the equator. But again, that is only the initial heading here. As you move along this line, the compass heading is always changing. And as the guy said in the video, if you take the reverse azimuth in this direction, it is not due west. So these are two paths that you can take from this starting point, and both of them have an initial heading of 90 degrees. So if you follow your compass is always going to be adjusting to north, and so you will follow the latitude line to the east. But if you're going to take the Great Circle route, it's going to be a lot more complicated, because this compass bearing is always going to change along this route. But the sun or sunlight is not taking a path across the surface of the Earth. So if we saw a sun over here, the compass bearing would be 90 degrees or due east. Now, in regard to Anthony's comment about the sun rising due east and setting due west on the equinox, yes, there are some websites that will say this, as this one does here. But other websites say what we actually see. This is from Earth and Sky. So it says on the equinox, on this day, the sun pretty much rises due east and sets due west. So what do we see in the real world? Here's three locations. I have Quito, Ecuador, which is almost right on the equator. New York City, which is almost 41 degrees north. And then Fairbanks, Alaska, farther to the north at almost 65 degrees. So this is from timeanddate.com for September 2019 for Quito, Ecuador. And on the equinox, which was the 23rd, the sun rises due east and sets due west. This is for New York City. And on the equinox, the sun rises 89 degrees, so it's off by about a degree and sets 270 degrees. And this is for Fairbanks. So again, we have a sunrise at 89 degrees, but sunset is 271 degrees. Of course, time and date is rounded these off to the nearest degree. So if we had fractions of a degree, both New York and Fairbanks would be different from each other. So Anthony is correct. On the equinox, we do not see sunrise exactly due east, nor sunset exactly due west in all locations. But of course, then he jumps to the conclusion that since this is a problem for the globe, it must be evidence of a flat Earth. But the question is, why didn't any of these panelists jump in at this point and show us how this works on the flat Earth and why the flat Earth would explain this phenomenon much better? Well, I think we know the reason for that. So here's a flat Earth map with all three locations, and the dotted yellow line is the equator. And of course, on the equinox, the sun would be orbiting above the equator. We also know that we have almost equal 12-hour days and 12-hour nights for all locations on Earth on the equinox. So the shaded area up here represents night, and sunrise would be to the right and sunset to the left. So if we put a compass on Quito, we can see that the sun should be rising at about 40 degrees. So it is about 50 degrees off from due east. For New York City, the sun should be rising at about 65 degrees, so it is off by about 35 degrees from due east. And from Fairbanks, the observed sunrise would be at about 75 degrees, so this is about 15 degrees off from due east. So let's compare flat Earth sunrise to what we actually see. And not a single one of them is even close to due east or to what the actual observed sunrise is. So which model best explains the equinox? Well, if you're a flat earther, you're just going to listen to the echo chamber and point out that the observed sunrise is not exactly due east for all locations on the equinox. Then you will gloat that this is evidence we live on a flat Earth, even though the flat Earth doesn't even come close to explaining this phenomena. And then it will be time for the next question. So here's a question. Can the globe explain this? Why, of course it can, and I'll be covering this in part 2.